Welcome you all for this lecture. Today we are going to explain you about email security from the Unit 5 of Cryptography and Network Security. Myself, Sherin Glory, Assistant Professor from the Department of Computer Science and Engineering from RMD Engineering College. So, email security, why it is important? What is an email? So, before moving on to what is email security, we must know what is an email. So, email is a distributed platform where where we do a formal way of communications. So, in today's world, all formal way of communications are taken place through only the emails. ஏதோ ரெஜிஸ்டர் பண்ணலான்னு போட்டிருக்காரு 131. Hence, it is important to provide and security for the email. So let us move on to this topic. So for providing email security, today we are going to discuss about PGP. So there are two platforms are available which is providing email security. One is PGP, another one is SMAN. Today we are going to explain you about PGP. So before moving on to the topic called PGP, first we have to know who is an email client and who is an email provider. Email client is the one who is providing the software or a platform to send and receive emails, where email providers are nothing but they are going to route or transfer the emails. So that is the difference between the email client and the email provider. So now we will move on to PGP. What is PGP? So PGP is expanded as pretty good privacy. It is an open source freely available software package for email security. So it provides authentication. How it is providing authentication is through digital signatures, confidentiality, through the use of symmetric block encryptions. And it also provides compression using zip algorithm and email compatibility using the radix 64 encoding scheme. So PGP incorporates tools for developing an public key trust model and public key certificate management. So let's move on. So what are the operations in PGP? So pretty good privacy. So these are the major operations in PGP. One is authentication, number two is confidentiality, number three is compression, and number four is email compatibility. So what do you mean by authentication? Both end parties has to know the identity of the users to whom the email has been sent and also from whom the email has been received. Knowing the identity is said to be an authentication. Confidentiality. So how we are going to achieve confidentiality through only encryption. Confidential means only the two end parties should know the message. No other persons in between the transmission channel may not be able to retrieve the message. It is confidential between only the two end parties. It is secret between only the two end parties. So this can be achieved using the message encryptions. And third one is compression. So since email we are going to support variety of data like videos, audios, images. So it may consume a large size. It is of large size. To reduce the size of that, we are using the compression and email compatibility. Many electronic email systems only permit uses of blocks of consisting of ASCII text. Here we are using radix 64 conversions. So where PGP provides the service of converting the raw 8-bit binary stream to stream of printable ASCII characters. So this is a summary of PGP services given. So what are all the functions? So to provide authentication, we are using the digital signatures, and to provide confidentiality, we are using message encryption, and the third function is compression, and the fourth one is email compatibility. So how we are providing digital signatures? Using your digital signature standards and secure hash algorithms. And message encryptions, we are using CAST or IDEA or triple DES or Diffie-Hellman or RSA algorithms. And for compression, we are using zip, and email compatibility, it is radix 64 conversions. So these are the basic services of PGP. So this has been depicted in a diagram. First one is, this diagram provides only the authentication. When a message has been generated, a hash code has been generated. Hash code can be generated using any of this SHA or any kind of algorithm. Okay, so then after generating the hash code, we are going to provide EP is nothing but public key encryption. So after providing public key encryption using the private key, so this has been the generated, since we are using a private key here. So this has been appended along with the message and then it has been sent for compression. So in the receiving end, it is decompressed and whatever message appended with the signature has been decrypted and it is compared with the hash code. Again, hash code has been generated and it is compared. If it's found to be the same, then it's said to be authenticated. It is from the right person. The second diagram says that confidentiality only. So first we are compressing the message itself at the very beginning and then we are going to provide an symmetric encryption using the session key, and then it has been after providing encryption the same using the same session key, we are going to perform a public key encryption and it has been appended together and then it has been sent in the transmission channel, and then at the receiving end both the signatures has been decrypted and decompressed and it has been received. So here we are taking part, we are concentrating only on the encryption of the message, that is security of the message. And the third one is the combination of confidentiality and authentication. So here we are calculating the hash code and then it has been public key encryption is done with the help of your private key and digital signature has been generated, that has been appended along with the message and then it has been compressed. Again, it is a combination of above two, right? So here we are using the entire thing, message along with the digital signature has been encrypted and sent in the transmission channel, and at the receiving end it has been decrypted again and decompressed again, and then signature has been calculated and compared to provide to find out the authentication. So this diagram explains you about the transmission and reception of the PGP message, whatever we have explained right now. So when a file has been generated, signature, if it is required, it will generate signature. If not, it will go on to compression algorithm. If confidentiality required, it will encrypt, and finally a conversion of RADIC 64 will happen. So the reception of the message, the reverse process. So whatever we done, the reverse process takes place. So RADIC 64 conversion, then confidentiality required. We, if done, we have to decrypt it. If compression has been done, we have to decompress it. And if signature has been generated, we have to strip the signatures. This is an overall diagram. So apart from that, we have cryptographic keys and key string in your PGP. So here PGP makes use of 4 types of keys. One is one-time session symmetric keys, public keys, private keys, and passphrase based keys. So these are the different types of keys used by PGP. So random number generated cast 128 has been used to generate the random numbers. So this is the general format of the PGP message. So where we have a key ID of the recipient at the top and then the session key that has been utilized for encryption, timestamp value to overcome the timing attack, and public key value and 2 octets of message digest and the file name, timestamp and the original data. So this is the format of private key ring. So where we have timestamp, key ID, public key, encrypted private key and user ID, and this is in format of your public key ring. Here additionally we have signature content. So this is an PGP message generation model. So the same diagram whatever we have discussed, that has been depicted in an elaborate manner. So message, hash code, encryption, and then this for the encryption where the key has been generated is it has been retrieved from the public key ring or private key ring. So similar to that we have a message reception also over here. So with this we have finished the PGP explanations. Hope you find it useful. So thank you.